Jai Hind everyone. My name is Dr. Ashish Dikshit. I am an associate professor in a computer science and engineering department in AKGEC Engineering College. So, dear students, today I will discuss about the growth rate of function and performance analysis of the algorithm. A performance analysis is an algorithm is said to be efficient and fast if it takes a less time to execute and consume less memory space at runtime is called a performance analysis. In a performance analysis, we will discuss about two types of complexity. First, a space complexity, and second is a time complexity. What is a space complexity? A space complexity of an algorithm is the amount of memory space required by an algorithm during course of the execution is called space complexity. There are three types of spaces. First, instruction space, it is also called the executable time program. Second is a data space, are required to store all the constant and variable data spaces. And next thing is called an environment. It is required to store environment information needed to resume the suspended space. Okay. And second option is also called a time complexity. How much time is required for execution of any program is also called a time complexity. Means time complexity of an algorithm is the total amount of time required by an algorithm to complete its execution. It is also called time complexity. Okay. So, let us here we will discuss about the space complexity. Okay. A space complexity of an algorithm is the amount of memory its need to run to the complete. Okay. Means how much memory space will be consumed if any program will be run completely. So, here space needed by an algorithm is given by the formula space complexity is equals to fixed part and second plus variable parts is also called space complexity. What is a fixed part? A fixed part independent of instance characteristics means space for simple variable or a constant is called fixed part. Second thing, a variable part, a space for variable whose size is dependent on the particular problem instance is also called variable part. Okay. Next thing, a time complexity. A time complexity of an algorithm is the amount of computed time its need to run to complete of our program is called time complexity. Means time complexity is equals to compile time plus execution time. Okay. So, step count in a time complexity, algorithm heading time taken 0 versus time taken 0 for expression taken 1 and any loop statement number of times the loop is repeating. These whole things will be considered in this. So, here we will discuss about the kind of analysis. First is the worst case. Here we will discuss about the three cases: worst, best and average. So, here we will discuss about the worst case. Usually a time complexity, maximum time of algorithm on an input of size n is called worst case. if the maximum time of algorithm on an input of size n is called a worst case complexity. Okay. Average time. If expected time of algorithm over all input of size n. Second thing, need assumption of statistical distribution of the input is also called average cases. Third thing, best case. A minimum time of algorithm on any input of size n is called best case. Okay. Next thing, a complexity referred to the rate at which storage time grow as a function of a problem size, okay, is also called complexity. Next thing, analysis of an algorithm. The goal of analysis of an algorithm is to compare algorithm in running time and also a memory management. A running time of an algorithm depends on how long it takes a computer to run the lines of a code of the algorithm. Okay, so here we will discuss about the speed of the computer, programming language and compiler and translator. Okay. So here we will discuss about the asymptotic notation and also called asymptotic analysis, expressing the complexity in terms of its relationship to known function. This type of analysis called a asymptotic analysis. Asymptotic analysis is to have a measure of the efficiency of an algorithm that does not depends on the machine constant, does not require algorithm to be implemented and time taken by program to be prepared. Okay. So, asymptotic notation, the mathematical way of representing the time complexity. The notation we use to describe the asymptotic running time of an algorithm and in terms of functions whose domain are the set of natural numbers. Okay. And the definition of the asymptotic notation, it is the way to describe the behavior of our functions in the limit or without the bounds. And asymptotic strategy, we will follow the growth rate is equals to time plus memory is also called growth rate. So here the rate at which the functions grow, growth rate is the complexity of the function or the amount of the resources it takes up the compute. Okay. So here we will discuss about the classification of growth rate function. So here we will discuss about the growing with the same rate, growing with the slower rate and growing with the fast rate. It's also called of function. Is also called growth rate of function. So here we will discuss about the growth rate of function. These are 5 types of notations. First is called a big O notation. It's a symbol big O. Okay. Then omega, then theta, then little o, then omega. Oh, okay. So here we will discuss about the big O notation. A big O notation, asymptotic less than slower rate. This notation mainly represented a upper bound of an algorithm runtime. It's also called upper bound function. Here big O notation is useful to calculate maximum amount of time of the execution. So here formula is apply, function fn is less than or equals to cgn and n is greater than or equals to n0, c is greater than 0, n0 is greater than or equals to 1. So according to big O notation, we will discuss about the definition of the big O. Let function fn, gn be two non-negative positive function. Now the function fn is equals to big O gn if there exist two positive constant c comma n0 such that fn is less than or equals to cgn for all values of n is greater than 0 and c is greater than 0. So this is the big O notation. It is the function fn and it is the function gn. Okay. So here this function is lower bound of cgn. This function is lower bound of the cgn. So we can say that fn is less than equals to cgn. And if we remove the constant, then we can say that fn is equals to big O gn. Okay. This concept is called a big O notation. So again we will discuss about the omega notation. Omega notation, asymptotic greater than faster rate if represent lower bound of an algorithm runtime. By using big omega notation we can calculate minimum amount of time. So we can say that fn is greater than or equals to cgn and n is also greater than or equals to n0, c is greater than 0, n0 is greater than or equals to n. So here where c is a constant, n is the function, lower bound and best case. These are the concept. Big O omega gn is equals to fn, there exist positive constants c and n0 and cgn is less than or equals to fn and cgn is greater than or equals to 0. Okay. So here this is the growth rate of the function. So here this is the growth rate of the function. This is the constant function and this is the main function. Okay. Main function is lower bound by the cgn, So here we can say that cgn is less than or equals to 0 and cgn is less than or equals to fn. So again we can say that fn is greater than or equals to cgn, then fn is equals to omega gn. Okay. This concept is called a omega notation. Next, theta notation. Everybody can say that theta notation is also called sandwich case. Means, how you will discuss about the sandwich? This is the function fn, and this is the function c1gn, and this is the function c2gn. Means main function will be lie between with two functions c1gn, c2gn. That's why it's also sandwich between each other. That's why we will call the sandwich case. So here asymptotically equality same rate if represent average bound of the algorithm running time. By using the theta notation we can calculate the average amount of the time. So it called average case time complexity of an algorithm. If main function is belonging from is lie between C1gn and C2gn, that's why we can say that C1gn is less than or equals to Fn, and Fn is less than equals to C2gn. Okay. So what is the function of the theta? This is the function of the theta. Okay. This is the lower bound. This is the upper function. This is the main function Fn. So we can say that Fn is greater than or equals to C1gn and Fn is less than or equals to C2gn. And then after we can say that Fn is equals to theta gn. Okay. Next, little o and little big O. It's a little o. It's a little o symbol notation is used to describe an upper bound that cannot be tight. In other words, loose upper bound of the function. So slower growth rate. So Fn grows slower than Gn, and it's also have the Fn equals to big O Gn, means Fn is equals to big O Gn. Okay. Next thing, little omega. It's also so that omega Another as a asymptotic notation is a little omega notation. It is denoted by the W. Little omega is notation used to describe the loose lower bound of the function. Okay. So here we will discuss about the Fn is equals to W Gn. Okay. So these are the references and these are suggested books and these are the references, and thank you very much. If you have any confusion, then write the comment in a comment box. Thank you very much.